In this video, we're going to look at two more examples where we're trying to find key features given a graph. So in this particular problem, the first thing we want to find is where this function is above the x-axis. And that would be represented with this notation here. Where is it above the x-axis? Okay. Now, remember, when we're finding where our function is positive or where it's above the x-axis, this is going to be an interval, and we're grabbing the values for our interval directly from the x-axis, okay? So I can pretty clearly see that the function is above the x-axis right at that little point there. But if I'm going to write an interval using that, now I have to look at the x-axis to get my values there. So let's see. Okay, remember this. If we have a point and it's located right on the x-axis, this is when it's neither positive or negative, okay? So I don't want to include this point here, but I want to get really, really close to it. So to do that, I would put parentheses, and then what x value would I be using? Because I'm writing an interval using values from the x-axis. So hopefully you can see this is 0 on the x-axis. And again, I use parentheses because I don't want to include that specific point, but I want to get really close to it. And then, where does it stop being positive? Well, this arrow notates to me that this is going to go on in this direction forever, right? This whole section is going to continue to be above the x-axis forever. So that means from the next value I need to get from the x-axis is going to be positive infinity, okay? Somewhere over here, off towards positive infinity, that whole section there, it will be above the x-axis. Oops, I put that in the wrong spot. That's my increasing, decreasing spot. All right, there we go. So that's where it's above the x-axis. In the next section, using this notation here, this is asking where it's below the x-axis. Where is our function negative, okay? So now we can see that section is definitely going to be from here to here, but how would we write that in interval notation, okay? So, if I'm reading this from left to right, remember, and I'm using values from the x-axis, it looks like right here, because our function stops here, it doesn't have an arrow, it's not going to go forever in this direction. But from this point, which would be -4, and then this is a little tricky. So for this -4, should I use parentheses or a bracket? Okay. Well, I can include this point because this point is completely below the x-axis. So I do want to include this point. Therefore, I will use a bracket. Comma. All right. And then where does this stop being below the x-axis? Well, right here at 0. Okay. And this point, since it's right here, it's neither positive or negative. I don't want to include that point. So I would put 0 and parentheses there. Don't want to include that point, but I can include this one because it's not right on the x-axis. All right, so there's positive and negative intervals. Now let's move on to where this function is increasing or decreasing, okay? And again, it's helpful for me to write like a little dude and kind of imagine him either walking up or sliding down the function, okay? So as he's doing this from left to right, so he would start here on the function because the function doesn't exist over in this spot here. The function only starts to exist at -4. So there he is at -4, and then he's walking up, right? Okay. It's not a very steep hill, but he is increasing. This function has a positive slope, okay? So it looks like from the value -4, remember we always use parentheses for increasing and decreasing, so from -4 all the way until forever, right? Because it looks like he's just going to keep walking uphill for the rest of his life, okay? So infinity is where we would close off that interval. Decreasing. Now this is a little bit weird, but it doesn't look, because he's just going to keep walking up forever, it doesn't look like there's any point or he's going to slide down. There's no point, there's no place in the function where the slope is negative, okay? So since there's no place where it's decreasing, we would say this does not exist. Does not exist, D and E, okay? All right, so there's increasing and decreasing, and then end behavior. So this one is going to get a little bit weird for this particular function, because you can see we have two boxes now, one for x and f of x. So let's look a little closer at what this means. So as x approaches blank, how would I have this here? Well, this looks a little bit tricky. Let's actually start with this one first, and then we'll come over to this one. So the other one says, as x approaches infinity. Okay, so remember this means as we're plugging in bigger and bigger values for x, so if we plug in 1, 2, 3, 10, a million, as we're plugging in those values, what's happening to our function? So let's say if I plug in 10, maybe really far over here, our function would be a little bit higher than it was before. 100, it definitely would be a little bit higher. So it looks like the y values, okay, the outputs are getting higher and higher. Those are increasing very slowly, but they're still going towards infinity, okay? All right, so that was the easier one. Now, I'm assuming that this one is having us look in the other direction. So as I'm plugging in smaller and smaller values, right? But why is there this blank box here? Well, the reason for that is that it looks like at some point I can't plug in certain values of x. Like I can plug in -1, -2, -3, -4. Could I plug in -5 though? Well, it looks like for this function, I could not plug in -5. I don't see an output for that. So this really breaks down after -4. So what I'm going to say is my end behavior, the end of this function, just like the end of this function over here went to infinity, the end of this, the other end of this function, has to stop at -4. That's where my x values have to stop, okay? So when I get to -4, what's happening to my y values, okay? So really, when I plug in -4, what is the output, okay? And that would be -2. As I plug in -4, because that's really the farthest point we can get to for our x value, my output would end up being -2, all right? So that was a little weird example, but most of the time you'll see those as positive and negative infinity. This is kind of just that weird extra case, okay? All right, and then lastly, let's find domain, range, and maxima and minimas. Get rid of all this stuff. All right, domain, that's how far to the left my function goes. It looks like that's the farthest to the left it goes, and we're getting my values from the x-axis, so that would be -4. Should I use brackets or parentheses? Definitely brackets, okay, because I want to include that point. It has a closed dot. Remember when we're finding domain, closed dot means brackets, okay? And then the farthest to the right it goes is forever. It goes off to the right forever towards infinity, okay? And we can never reach infinity, so infinity is always going to have parentheses, okay? Even negative infinity, like in the values that we had up here, right? Negative infinity or positive infinity, anytime you have those, they're always going to have parentheses next to them. We can never reach them. All right. There's the domain, and then the range, that's how low the function goes. So the lowest value it reaches, if we're looking at the y-axis now, that would be -2. That's the lowest it goes. And brackets again, because I'm including that point, it's a closed dot. And then the highest up it goes, well, it slowly goes up, right? That's what we looked at when we were finding where it was above the x-axis. It was going up forever. So slowly but surely it goes to all of those y values, those positive y values, okay? And then maxima and the minimas. Do you guys see any hills or valleys in this? So I don't see any places where there's a distinct hill like this. There's no valleys, okay? That's what I'm looking for maximas and minimas. So unfortunately, this one does not have a maxima or a minima, and that can happen, remember, where there can be neither of these. So again, we would put does not exist and does not exist. Okay, so that was example number 1, and then we'll go through one last example. Zeros. What does that mean? Okay, well, zeros is just another word for my x-intercepts, okay? Not the y-intercepts. I don't care about y-intercepts at all. This is just asking where my function touches or crosses the x-axis. So that's going to happen at these 2 points here and here. So 1, 0, and -3, 0. Okay, great. How about where this function is increasing and decreasing, okay? So bring out my little dude. Where is he walking up? Where is he walking down? So let's focus on increasing first. So here it looks like he would be sliding down, right? So that would be, in the future, that would be my decreasing interval. But then right about here, he's having to do the hard work of climbing uphill, and that's going to happen from -3, parentheses. Remember, for increasing and decreasing, never use brackets, always parentheses. And then he finally rests atop the peaceful mount at -1, okay? But then he slides down again and has to do some more work at this last section over here, right? This is where he's climbing up a huge, huge hill. So from 1, that's another interval, from 1, and then he's climbing up for infinity. He's going to climb the mountain for the rest of his life. All right, so hopefully you can see that we have an interval, right, from here to here. That's where he was climbing uphill, and this other interval from there to there. To connect these intervals together, do you remember the symbol that we use in between them? Okay, the union symbol. Okay, so we have these two intervals. We want to talk about them together. These are the two places where it's increasing, so we have to unite them together with a union. Okay. All right, so that was increasing. Can you see the places where the function is now decreasing? Okay, let me get all this out of the way. So where is he sliding down? So hopefully you can see that that would be from here to here. That's where he would slide down, as well as this point there. So how would I write that in interval notation? Okay, so that first interval, because I'm reading this from the left to the right, well, that would be from -infinity. So I'm using the values from the x-axis, so from -infinity to -3. All right, and then I'm going to have to put a union because it looks like I have another interval here from -1 to +1. Okay, so that would be my interval for increasing, my two intervals that are united together, and my two intervals that are united together for decreasing. Okay. All right, awesome. Now let's check out the end behavior. So let's get rid of this little guy and test this out. So as my x values approach -infinity, so as I plug in smaller and smaller values for x, -1, -2, -3, -4, what's happening to our function? It looks like it's shooting up towards infinity, okay? Right, like if I plugged in -4, I get this value, -5, I'm probably going to get a way bigger value that's up there. So my y values are going up towards infinity. And now, on the other side, if I were to plug in bigger and bigger numbers for x, I plugged in 2, maybe 3 over here, it looks like it's doing the same thing, right? On the other side, the values just seem to shoot up towards infinity. Okay, they get bigger and bigger and bigger. So again, our output is going to tend towards infinity. It's going to approach infinity. Right, and then we got domain and range. So the farthest this function goes to the left, well, it's slowly creeping over to the left, as you can see, and it will continue to slowly creep towards the left for infinity. So I would say from -infinity, and same thing on the other side, to +infinity, that would be the domain, okay? Range. All right, well, the lowest this function goes is right there. Now I'm getting my values from the y-axis, okay? So that's the lowest it goes, which on the y-axis, that would be 0, okay? And it looks like I have solid points, closed dots for both of those points that are the lowest ones. So I'm going to use a bracket for that. And then how high does this function go? So be careful not to be tripped up by this, okay? This point is not the highest point, because remember on either side here and here, this function is going up forever, okay? So this outweighs what's happening here. The function is going to go up forever, so our range would be infinity. Next, I have my maximas and minimas. So what are the hills and the valleys? So there's definitely a hill right here at -1, 16. There's only one maxima, and that's it. And then it looks like there's two minima. So those two values here and here, those two valleys, the lowest point in the valleys, at 1, 0, and -3, 0. Excellent. All right, and then the only thing left is we now have to find the average rate of change. So I'm using my trusty slope formula to find the average rate of change. And it wants me to find that, it looks like from this maxima that's here to this other minima there, okay? So from that maxima to the minima, what's the slope? I'm already going to guess that I'm going to get a negative number because it looks like I do have a negative slope. So let's see what I get. Let's label this first. So x1, y1, x2, y2. Let's go ahead and plug this in. So I get 0, minus 16, all divided by 1 plus 1. Remember, I have a negative. The negative makes a positive there. Okay? So negative 16 divided by 2, and I get -8. So that's exactly what I was looking for, right? A negative number. So I know I did this correctly. I have a negative slope. I'm getting a negative number. That would be my average rate of change.